Alright, CNT120, Chapter 3. This chapter we're going to be focusing on addressing on our networks. So the first podcast, I'm going to do just kind of a general overview of all the addressing. Then we'll come back in future podcasts and do specifics. So, the beginning of the chapter, like the first page or two here, they do a super quick overview of the four main types of addressing we're going to talk about, and four main types of addressing you'll encounter in networks. Data link layer address, MAC address, network layer address, IP address, transport layer address, port numbers, and application layer addressing, or fully qualified domain names or domain names. So real quickly, here's the real quick blurb on each of them just to kind of get the ball rolling. At our data link layer, we have the MAC address. This is the address that's burned into every NIC. And this gets used to help identify a computer on a LAN, a local area network. This is a 48-bit long address. If I were to write out in binary, ones and zeros, it would be 48 bits long, 48 ones and zeros. But it's you'll typically see it as a hex number, 6 hex numbers. This shows up as like 12 hex characters, if you will. So if I look here, these two are literally a hex number, but as I look down the line, I end up seeing 12 of those digits, if you will. 12 hex digits, but actually 6 hex numbers. And here, each of these, as I look at them, kind of right here, each one of those is 8 bits. So 6 of those times 8 is 48 bits. That's where that comes from. This is used to find LANs, devices, nodes on a LAN. If you remember switches working at layer 2, check and read MAC addresses and move data to the correct MAC address. So switches on our network are reading these MAC addresses and trying to get the data to only one computer, only one node, if you will. So these MAC addresses get used by switches, and switches are trying to get data to the correct node on our local area network. Now, depending on what you read, what you hear, there are multiple names for our layer 2 address, our MAC address. You will find it also called a physical address because it's physically burnt into the NIC. You'll hear it called an adapter address because it is, burnt into our network adapter. You'll hear it called a layer 2 address because it occurs at layer 2. You'll hear it called a data link layer address. And you'll also hear it called an Ethernet address because we have an Ethernet NIC on an Ethernet network, so technically it would be an Ethernet address. So you're actually going to hear all of these names for this layer 2 MAC address, if you will. So just kind of like chalk those up in your brain and realize when somebody says an Ethernet address, they're talking MAC address. When they say physical address, they're talking MAC address, that sort of thing. The next type of address we run into is our IP address. These are assigned to pretty much every interface, every node connected to a network, including router interfaces, those sorts of things. These can be used to find a computer pretty much anywhere in the world if it's connected to the public internet. So this gets used to find a computer, kind of in a vast array of networks. As I like to say it, this is really here to get the data to the correct network. And I'll go back a slide here. The MAC address would then be used to get it to the correct node on that network. That's typically how it goes. These are used for routing purposes. Our routers read these addresses, so they're moving data to the correct network. The routers are trying to route the data to the correct network. And again, you're going to hear multiple names for this address. It's a logical address because there is actually, when I look at this number, there is actually some logic to where it's located. It's called a software address because I actually am changing it in software and I can change it in software. It is called a layer 3 address because it occurs at layer 3. And it's also called a network layer address because that's our layer 3, our network layer. We do run into, there is IP4 addressing and IP6 addressing. IP4 addressing has been the standard for a long time, and IP6 address is relatively recent, and most networks are now starting to use both with the eventual migration to hopefully IP6 in the future. IP version 4 is 32 bits long, so if you write it out in binary numbers, as a binary number, you'll have 32 ones and zeros, but it's typically written as 4 decimal numbers, something like we have here, 92, 106, 50, 200. And when we do some math on IP version 4 addresses, yes, there is a lot of them, but we have run out of IP version 4 addresses with all the devices that we have connected to our networks. If you think about just your house, the number of laptops, tablets, devices, including phones and those sorts of things, you have quite a few addresses in your, quite a few devices on your network at home. Those would be quite a few IP addresses that you're using. IP version 6 addresses have come along as a replacement for IP4. These are 128 bits long. Again, if I write it out in ones and zeros, I end up with 128 ones and zeros. But it's typically written as a shorthand of hexadecimal numbers. And it is, as we see here, 8 blocks of hex numbers. Okay, so if I actually calculate all those out, we have 8 bits here, and then 8 bits here. So there's 16 here for each of these. Multiply that out, you end up having 128 bits. There's our 128-bit IP version 6 address. Reminder, I do have materials out here for helping you with binary and hexadecimal, and we will need to do some binary and hexadecimal conversions. Binary, we tend to, when we work with IP4 addressing, we tend to do some of it in binary, especially when we work on subnet masks and subnetting. So there is some knowledge, some knowledge we should have of binary to be able to work with IP4 addressing. Hexadecimal, as you noticed, our IP version 6 addresses are written in hexadecimal. So working with IP version 6 addressing, it is actually handy and useful to have some knowledge in hexadecimal. So again, on the content page, there is materials for helping with binary and hexadecimal. Please use those. Please refer back to them to help you. These are some foundations that will help down the road as you work with these addresses more. As we move up to the transport layer, we run into port numbers. Port numbers used to identify an application that's running on a system. I like to say here, think about your PC that you have. At any given time, you probably have multiple different processes running. Example, you might have your browser open, and in one tab you have your email, and another tab you might have things for a class, but you also might have streaming in the background, some sort of music, Spotify, Pandora kind of thing, and you might even have some other tab open with another resource. Well, your computer needs to know where all of those are and what they are, so data coming in, it can get to the correct tab or the correct application or utility that you have running on your laptop or desktop. Port numbers are how your device knows, oh, this is a piece of web page, oh, this is a piece of email, this is a piece of my music stream. That is how your computer knows those apart. That's what port numbers are for. Last type of addressing we have is application layer. This is our fully qualified domain names, basically our domain names. Every host has assigned a unique character-based name, and this is for us humans, so we know it's this computer as opposed to that computer, or this server as opposed to that server. So my fully qualified domain name would be stuff like, dlbrown.hack.edu or www.hack.edu, the actual hack homepage. Okay, that's how we can find those resources. Well, there are two parts. We have the actual domain name, and we have the host name. So the end of it here, hack.edu, is the domain name. Meanwhile, the beginning part is the host, or in some cases, even the actual service for that. World Wide Web is going to imply it's a web server for the hack.edu domain. Okay, so that's all part of my domain names. That's the last addressing we'll talk about in this chapter. We do need to remember that the organizations responsible for all of this is IANA and ICANN. Starting down here at the bottom, ICANN, Internet Corporation for Assigned Names and Numbers. This is charged with setting a lot of policies on how the Internet works. A subgroup of that is IANA. IANA, Internet Assigned Numbers Authority, their responsibility is really keeping track of domain names. What is www.hack.edu? What is that? Port numbers for various applications. If I'm going to run a program like OpenVPN, what port number does that use on a system so that we can get to that resource? IANA and ICANN are overlooking these things. If I pull up IANA here, here's the IANA page, here's domain names, resources, protocol assignments, etc. We'll be looking this as we get to that part of our chapter. So they're the groups that are kind of overseeing a lot of what we're talking about in this chapter. All right, when I come back in the next podcast, we'll dig into the first type of addressing, our data link, our MAC address.